Okay, let's continue watching the on-site interview example 1.
I have another question. Let's say...
Sure. Doing the marker?
No, I don't need the mark. I'm just asking. Let's say that if you want to reverse all the vowels of all the books in a library.
Okay.
Like there is a library, physical library. It has 1 million books.
Yes.
It is sorted by some order. Let's say the book has the index, and this book is index 0, this is 1, this is 2, and then 999,999.
Yeah.
And then we open the book, there is a whole bunch of letters, and we want to reverse this vowel to the end of the like the last book, and then keep reverse all the vowels.
Yes.
So basically what I mean is that it is impossible to
store
whole string in the memory.
Yes.
How would you do that? Do you think of any algorithm?
So, which means the string is already stored in the, like the text is stored in the disk. And
Yes.
You can read it. Right?
Yes.
Can you read it from behind?
Yes, random access of the file is possible.
Okay, random access of the file is possible.
Mm-hmm.
So this algorithm still works, right?
Yes. Yes.
And well, and it's the same complexity.
But no, if you read character by character,
Yes.
if you read one character from one file and then another character, keep reading characters and keep reading characters.
Yes.
And then if you find the vowel here and vowel there, you're gonna swap them, and then you're gonna do the write operation
Yes.
on file, and then you're gonna keep looking for another vowel here and the vowel there, and then you're gonna do a write operation here and there. Okay. This is a file. Do you think is it efficient enough? Is there any good way to make it more efficient?
Yeah, there should be. The best way is like if you allow extra disk, you read from the behind of the from the end of the file to the bottom to the front, and you keep reading. And once you find a vowel, you write it to a separate file.
Okay.
And then the vowels are already in a reverse order from the original file, right?
Oh.
And then you scan the original file once again from the beginning to the end. And once you encounter a vowel, and you just replace it replace it with the thing from the end, the separate file you written already.
Okay. So you're gonna store all the vowels into a separate file.
Yes.
And then you're gonna read the file from the end toward the beginning, and then you're gonna rewrite all the vowels to the file sitting in the disk.
Yes.
So, can you think of like a worst case scenario?
You're saying like, because replacing something in a file with same character size shouldn't be very costly, right?
Okay.
Is that costly? I'm not sure.
Well, I think writing the characters something into file is actually the block-based processing. So usually the file reader and the file writer does like a block-based. It also a cache layer, so it writes something onto the cache, and then it actually reads blocks by blocks and blocks into the cache first, and then read the caches.
Okay.
Yeah.
So which means you want to minimize the number of times you write into the file.
That should be good.
Okay.
Yeah. One way is to actually use like a file buffer, so that you're gonna have some memory, and then you're gonna read the string and then load it to the memory.
Yes.
And then write everything you like, and then you're gonna call some flush function, and then this will be written into the file.
Yes. So basically, everything you want to write is temporarily stored in the cache, and then write into the file.
Yes. Okay. So again, you have a whole bunch of characters in the file.
Yes.
And then you're gonna read everything. You find all the vowels, and then write like vowel.txt file and put every vowels into the vowel file, and then you're gonna read from the end toward the beginning and then rewrite everything.
Yes.
What is the worst case again? I see some really worst case.
So the worst case is everything is a vowel.
Yes.
And you just read everything and write everything.
Yes.
So it takes you a lot of disk space equal to the original file.
Yes.
Okay. Yeah, that's true. Maybe you can do because because I guess the best way to do this is like divide the file into blocks. And for instance, if a file is 10 gigabytes, and you divide it into like 10 megabytes blocks one by one, and then you first like read the first, and you have a temporary, like as I said, you still have a temporary file which stores all the vowels.
Yes.
And the maximum size of it is 10 megabytes.
Okay.
So if you keep reading from the end, if it's running out of if it's running out of like vowels, and if it's so it works like a queue, right?
Okay.
So and if the like actually probably if you can store 10 megabytes in the memory, like you don't really need it.
Yes.
So then it serves like a queue, and if you're running out of it, you read from the end. If you have too much, you read from the beginning and replace those.
So you will have a vowel queue.
Yes.
Like a left queue and right queue. You're gonna read the file up until the queue fills.
Yeah.
And then until the queue fills, you're gonna read the file from the end, and then you're gonna once both of them fills, you're gonna swap and then write back to those files.
Yeah, I think so.
Okay. Okay. Makes sense.
Okay.
Yeah, which is actually what you just described is the efficient way.
Okay.
So it is like you do chapter by chapter.
Yes.
Like a book has a chapters and pages, and if you read all the vowels for some chapter, like first chapter in the first book and the last chapter in the last book, read all the vowels, swap it, and then do the swapping again.
Yeah.
Yeah. So then, is there any better way to make it faster?
Like I don't really understand the goal of it, because since you want to minimize the time when you write it, because I assume you want to write it block by block rather than write it one by one. So then you make the block size the maximum, like how much you can store in the memory, because anyway you have to store all the vowels in that block.
Okay.
That's the minimum, like that's the best case you can do, right?
Okay.
So you try to store as much as in the memory and try to replace it and then write it back.
Okay.
So I think that's pretty much the previous solution did.
Okay.
So I don't see a better way, I guess.
Okay, good. Yeah, that's good. Thank you. Yeah. Cool. Yeah, I have another question. It's still the string question.
Okay, sure.
The question here is, let's say I have two strings.
Yes.
One string is ABC.
Yeah.
The other one is ABXD.
Okay.
For the two given input string, I want you to find the character inserted to the other string. So the difference between the two input strings will be only one character.
Okay.
And you're going to find that inserted character.
Okay, so basically the second string is one character longer than the first one?
Yes.
Because it's inserted by one string?
Yes. Can you think of which is the right way, which is the efficient way to detect?
I mean, the most naive solution is just scan from the front to the end. So if so, we can simply find the first character which differs, and then we can find out what is the actual character inserted.
Okay.
So, which takes O(n) time. So I assume there might be a better way, like faster than O of n. How about we can do something like a binary search, but I'm not very sure about that.
Okay.
Let's say we have two strings A, B, C, D, E, F, and A, B, C, C, D, E, F.
Okay. And then, like in this case, can you find C or return values C?
So we can return either of those, right?
Either way.
Just return a character.
Yeah, just return the character.
Okay, sure.
So C may be shown in these characters. Maybe X, maybe Z, some new character, or it may be some additional character here. You understand?
I see. If those two strings are random, like if the origin string has a like an even distribution of all the characters, it is possible. Otherwise, I don't think it's possible, because the worst case is you have a bunch of A's in the original string, and in the secondary string, you have a random B in a bunch of A's.
Okay.
And I feel anyway it takes you out of n time to find this B.
Yes. Okay. How about this? You're correct. In any cases, you need to go through all the characters and then detect. Hence, this is different. How about this? You have different order. Like for this example, let me write it C, B, A, D, and then A, B, X, B, C. It should be D. No.
It should be 1B, 1D.
This, which is better? B and this is D, like that.
Okay.
So the number of characters are different. This has one more character.
Yes.
And then all the characters are the same except this character.
Sure.
Or let's say that if it is 5 characters, let's see, this is C and this is B. So originally,
I see.
1A, 2, 1B, 1D, and but 2 C's. 2 C's are here, 1A, 1B, 1D, but we have an additional character. Like in this case, can you find X here?
Yeah. So if the alphabet size is relatively small, we just need a hash table. Basically counts how many what's the occurrence of each character.
Okay.
Then we'll eventually find a character which has one extra occurrence.
Oh, okay.
And that's the one.
Yeah.
Okay.
So you're gonna have a hash table. Basically, everything is empty, but currently C comes in here, A comes in there, and you're gonna count basically histogram of all the characters.
Yes.
And then you're gonna look through all the characters again, and then try to detect which has the one more character.
Yeah, that's right.
Okay, great. Then, like in this case, you're gonna read all the characters.
Yes.
And then you're gonna put everything into some histogram.
Yeah.
And then detect it. And probably you're gonna read everything. So the worst case, of course, still the complexity is
Out of n.
Yeah. But this actually read twice the characters, right?
No, you didn't read twice.
In the worst case.
You read every character once, right?
Yeah,
Because there are
yeah.
n strings and n strings. So n characters, you takes you 2 times n time. Right?
Yes.
It takes n time to read the first one, 2 takes n time to read the second one.
And the worst case is the A, B, C, the Z, and then A, B, C, this is Z, X.
Yes.
So if there's a 26 characters, 27 characters, and then you're going to put everything into hash, in this one everything goes to hash, and then you're going to read through every items and hash table.
I mean, yeah. Anyway, you have to put everything into the hash and count the occurrence, right?
Okay.
Yeah. Saying like you don't have to read the whole string or something.
I think you have to basically go through every character.
Yeah.
You have to visit every character.
Yeah, because every character makes a change, so you have to read everything. Otherwise, I don't think there is a better solution. This looks like a lower bound.
Okay. Yeah. So I agree that you're gonna go through every character.
Yes.
That's unavoidable. Is there any better way? Is there a good way to easily detect X here?
You mean by not reading all the? I don't really understand because I think the previous solution already. Is there any drawbacks of the previous solution or something?
I think it is fine, but okay. Let's switch the question.
Okay, sure.
Okay, you have 2 sets of numbers.
Yeah.
Like 2, 3, 5, 7, 13, 10, and another set has the 2, 3, 7, 13, 10, 5, 6.
Yeah.
Like among these 2 sets, can you detect 6?
Yeah, you just sum it up.
Okay.
Take and subtract, right?
Okay.
Yeah, and you can do the same thing for here.
Okay.
And I see what you mean. Yeah, it's better. I guess the most easy way is to do an XOR. Yeah. You just XOR all the characters.
Okay, you will XOR all the characters and XOR all the characters.
Yeah.
And then
the final result is the thing you want.
Oh, so you mean to just keep XOR in all the characters?
Yeah.
Continuously?
Yeah, you don't really care about whether it's in the first string or second string. You just XOR all of them. And I guess this only takes order of one memory. I think it's works better for a huge alphabet size.
Okay.
Yeah.
Okay, great. Yeah, that's correct. XOR is like A XOR A is equal to 0.
Yeah.
Right, and then A XOR A is equal to A.
Yeah.
Okay, that's great. So you can try similar thing here. How about this? Come on, 1.
Okay.
So it has two new numbers inside these two sets. Can you find
yes
those two numbers?
You can do a XOR and then you do a addition.
Oh, okay.
And you get two numbers, right?
Oh.
And you can do it by solving the equation. I guess so. I'm not really sure. I think we can.
So you have two operators.
Yeah. Basically you have two numbers, and you know their XOR result, and you know their addition result.
Okay.
And you want to figure out what's the actual number there.
Okay.
Let me see if it's possible. Maybe it's not possible.
How about other operation?
Yeah, let me see. Oh, the easiest way is like you can do, but you don't want to do. You don't want to do time and divide because it's too big.
Oh, time and divide.
It's too big, right? You can certainly find out their sum, and you can find their product if you do time and divide.
Oh, okay. Sum and product. So you're gonna sum all these up.
Yeah.
And sum all these up, and you have sum of A and sum of
B. Yeah.
B. Not this sum. And also multiplication of A and multiplication of B.
Yeah. And then you. Like if say it's B is bigger than A, like it's a large size, so you can like sum of B is subtract sum of A and the product of B over product of A.
Okay, sum of B minus sum of A will have those two numbers. Let's say this is
X, Y.
X and Y, this is X plus Y, and then multiplication of B
over multiplication of A.
Multiplication of A is equal to
X times Y.
X times Y. Okay, so times Y. Okay.
There's only a drawback, like because all that are integers. If you take the product of all the integers, it might be too big.
Okay.
Like you have to either do a high precision or something, or you can just take the logarithm and add those up. Like could potentially work, but you lose some precision over there.
All right. If you just there are too many numbers in this set. If you take logs of everything, and then you will not hit the overflow, but your answer may not be exactly 6 and what, it's 6.0001.
Yeah, you get some precision error. And if the numbers gets too much, like you basically lose the precision.
Yes.
And that's why I said like XOR could be better. So basically we can have a sum and we can have its XOR, but I don't know if it's possible to figure out X and Y.
Okay. But if it is XOR, it will be like XOR of all B, XOR of all A, but just XOR of all B, and XOR of all A.
Yeah, and then you get X XOR Y.
Yeah, X XOR of Y.
Yeah.
And then
I don't know if these two can combine together, can find out this. Yeah. I think it's possible.
Okay, that's good. Cool.
Do you want me to figure this out?
Well, as long as I know there is no easy way to.
Okay.
Unfortunately, there could be some research paper that do something. I don't know.
Okay.
Somebody have already studied that, but as long as I know.
Yeah.
As long as I know, there is no easy way to figure out X and Y from the summation of everything and then XOR of everything.
Oh, really? There is no. I'm not sure.
I don't know.
Okay, sure.
Cool. Yeah. Okay. That's it.
Okay.
Yeah,
great.
that's all question that I have. Yeah. Do you have any question?
Yeah. Do you enjoy working at a company A?
Yes, I really enjoy. Yeah. all team members are great.
Oh, cool.
And the projects are really good. I really like the project, and we have already launched the product already. And then we're gonna launch another set of products soon. So and then we're gonna deprecate the old product.
Oh,
so
that's great.
there will be two additional projects. One is they launch the new projects, and then another project is deprecate the old project. You know the complexity of deprecating the old one from an existing pipeline.
It's kind of painful.
It's really painful.
Yeah.
It's hard, and then even though we design initially well, it is not. It gets dirty as time goes.
I see.
And then adding a new code to the system is fancy and beauty, but removing out all the cross-connected code is not simple.
I guess you want to also keep the pre-existing code work during the migration.
Exactly.
Yeah.
It is a service. It shouldn't stop at all. The customer should not notice anything.
Yeah.
Awesome.
I guess.
Awesome. Yeah, great.
Cool.
Thank you. So
Yeah,
next
thanks.
interview will come, and then
All right.
have
Cool.
fun, and then hope you see you again.
Yeah. Thank you.
Bye. Bye.
Bye. Bye.
Okay, how do you think about this interview? Did he did well or bad? Let me give you my feedback. First of all, coding. I think he has a quite strong coding skills. He has a consistent coding style, and he has a good data structure knowledge. During the interview, he made several mistakes, but he fixed by himself without much help or advice from the interviewer. Analytical skills. Actually, the 3 interview questions does not require any strong algorithm development, so it is hard to measure his analytical skills. But overall, he knows how to analyze the algorithms that he proposed, and he applied his analytical knowledge to solve the problem in an optimized manner. For the second question, he has some difficulties for solving the problem in a large scale, but it is fine. He was able to accept my hints, and then he reached the goal. Communication skills, he does not have any problem in communicating with others about what he thinks, what he proposed, and he knows how to interact with the interviewer. And overall, he has a quite pleasant voice tone, which is also a plus. So overall, I would give quite high score, 3.1. 1.0 is a very low score. We need to reject this candidate. 2.0 is still low score. We want to reject this candidate. 2.5 is the borderline candidate. Basically, it is hard to make a decision. And 3.0 is a strong candidate. The candidate did very good job in all aspects. And 4.0 is the best score. I do not expect anybody could get the 4.0. 3.1 is a very high score. He did a very good job. Overall, he has a quite strong coding skills. He codes quite fast, and his problem-solving skill is also good. And I felt pleasant to talk with the candidate. So yeah, we want to hire this candidate. Again, in this session, we watched the video of actual on-site interview. He got his bachelor's degree in computer science. Previously, he had one software engineer internship experience. Considering all this, during the interview, he did quite good job. So he's quite strong. So if you could do in your on-site interviews like he did, you should be good. That's it for the first example of on-site interview.